Welcome to our Azure Key Vault tutorial. Azure Key Vault, a cloud service provided by Microsoft Azure, empowers you to safeguard and manage cryptographic keys, secrets, and certificates used by cloud applications and services. In this tutorial, we'll guide you through the fundamentals of Azure Key Vault, from its basic concepts to practical implementation. By the end of this tutorial, you'll be equipped with the knowledge to enhance the security posture of your Azure applications through effective key and secret management. Let's dive in. Here's the list of topics we are covering in this video. Introduction to Azure Key Vault. Getting started with Azure Key Vault. Key Vault Basics. Access control and permissions. Key rotation and versioning. Monitoring and logging. Azure Key Vault integration. Best practices and security considerations. Use case scenarios. Hands-on labs. 1. Introduction to Azure Key Vault. Overview of Azure Key Vault. Azure Key Vault is a cloud service provided by Microsoft Azure, designed to safeguard sensitive information like cryptographic keys, secrets, and digital certificates. It acts as a secure vault to store and manage these assets and ensures that they are protected from unauthorized access and vulnerabilities. Key Vault provides a highly scalable, reliable, and fully managed solution for cryptographic key management and secret storage. Use separate key vaults. Microsoft recommendation is to use a vault per application per environment, development, pre-production, and production per region. Granular isolation helps you not share secrets across applications, environments, and regions, and it also reduces the threat if there is a breach. Key Vault benefits. Security. Azure Key Vault offers robust security features, including hardware security modules (HSMs) and strict access control to protect your keys and secrets. Scalability. It can handle large-scale deployments and is highly available, making it suitable for enterprise-grade applications. Simplicity. Key Vault simplifies the management of cryptographic assets, saving time and effort. Integration seamlessly integrates with various Azure services, streamlining application development. Monitoring provides auditing, logging, and monitoring capabilities to track and respond to security incidents. Disaster recovery offers backup and recovery options to protect against data loss. Here are other important terms. Tenant. A tenant is the organization that owns and manages a specific instance of Microsoft Cloud Services. It's most often used to refer to the set of Azure and Microsoft 365 services for an organization. Vault Owner. A vault owner can create a key vault and gain full access and control over it. The vault owner can also set up auditing to log who accesses secrets and keys. Administrators can control the key lifecycle. They can roll to a new version of the key, back it up, and do related tasks. Vault Consumer. A vault consumer can perform actions on the assets inside the key vault when the vault owner grants the consumer access. The available actions depend on the permissions granted. Managed HSM administrators. Users who are assigned the administrator role have complete control over a managed HSM pool. They can create more role assignments to delegate controlled access to other users. Managed HSM Crypto Officer/User. Built-in roles that are usually assigned to users or service principals that will perform cryptographic operations using keys in managed HSM. Crypto user can create new keys but can't delete keys. Authentication. To do any operations with Key Vault, you first need to authenticate to it. There are 3 ways to authenticate to Key Vault. Managed identities for Azure resources. When you deploy an app on a virtual machine in Azure, you can assign an identity to your virtual machine that has access to Key Vault. You can also assign identities to other Azure resources. The benefit of this approach is that the app or service isn't managing the rotation of the first secret. Azure automatically rotates the identity. We recommend this approach as a best practice. Service principal and certificate. You can use a service principal and an associated certificate that has access to Key Vault. We don't recommend this approach because the application owner or developer must rotate the certificate. Service principal and secret. Although you can use a service principal and a secret to authenticate to Key Vault, we don't recommend it. It's hard to automatically rotate the bootstrap secret that's used to authenticate to Key Vault. Encryption of data in transit. Azure Key Vault enforces Transport Layer Security (TLS) protocol to protect data when it's traveling between Azure Key Vault and clients. Clients negotiate a TLS connection with Azure Key Vault. TLS provides strong authentication, message privacy, and integrity, enabling detection of message tampering, interception, and forgery, interoperability, algorithm flexibility, and ease of deployment and use. Perfect Forward Secrecy, PFS, protects connections between customers' client systems and Microsoft Cloud Services by unique keys. Connections also use RSA-based 2048-bit encryption key lengths. This combination makes it difficult for someone to intercept and access data that is in transit. Disaster Recovery offers backup and recovery options to protect against data loss. Key Vault Pricing. Pay-as-you-go. Key Vault pricing is typically on a pay-as-you-go model. You are billed for the transactions and operations you perform with your keys and secrets. Transaction-based costs. Key Vault pricing includes charges for key operations like creation, retrieval, and deletion, secret operations, and cryptographic operations, e.g., encryption and decryption. The cost depends on the type and quantity of these operations. Secrets and keys. The costs may vary depending on whether you're using Key Vault for secrets management, keys, or both. Pricing can differ for various operations related to these. Pricing tiers. Microsoft offers different pricing tiers, standard and premium, which can affect the cost of using Key Vault. Premium tiers may provide features like HSM, Hardware Security Module, protection, which can have higher costs. Data transfer costs. Data transfer costs may apply if you are moving data in or out of Key Vault, such as importing or exporting keys and secrets. Our operations defined in Key Vault. Every successfully authenticated REST API call counts as one operation. Examples of operations for keys: create, import, get, list, backup, restore, delete, update, sign, verify, wrap, unwrap, encrypt, and decrypt. Note that the price charged for an operation may vary based on the type of key. For example, operations performed on a 2048-bit RSA key versus a 4096-bit RSA key are billed against different meters with different prices as described in the pricing section above. Examples of operations for secrets: create/update, get, list. Examples of operations for certificates: create, update policy, contacts, import, renewal or update of certificates. Note that a certificate renewal operation has a separate cost from all other operations on certificates. Availability. Regional availability. Key Vault services are available in multiple Azure regions around the world. You can choose a region to host your Key Vault based on your requirements for data locality, compliance, and availability. High availability. Key Vault is designed for high availability. It's replicated within the chosen region to ensure data redundancy and reliability. Redundancy options. Azure offers various redundancy options, such as geo-redundant and locally redundant storage, to enhance the availability of your key data. Service Level Agreements, SLAs. Azure Key Vault typically comes with SLAs guaranteeing a certain level of availability. These SLAs may vary depending on the pricing tier you choose. Compliance. Key Vault is designed to meet various compliance and security standards, making it a suitable choice for applications with stringent availability and security requirements. Azure Key Vault features multiple layers of redundancy to make sure that your keys and secrets remain available to your application even if individual components of the service fail. The contents of your Key Vault are replicated within the region into a secondary region at least 150 miles away, but within the same geography to maintain high durability of your keys and secrets. If individual components within the Key Vault service fail, alternate components within the region step in to serve your request to make sure that there's no degradation of functionality. You don't need to take any action. The process happens automatically and will be transparent to you. Failover in Azure Key Vault. In the rare event that an entire Azure region is unavailable, the requests that you make of Azure Key Vault in that region are automatically routed, failed over, to a secondary region, except as noted. When the primary region is available again, requests are routed back, failed back, to the primary region. Again, you don't need to take any action because this happens automatically. Through this high availability design, Azure Key Vault requires no downtime for maintenance activities. There are a few caveats to be aware of. In the event of a region failover, it may take a few minutes for the service to fail over. Requests made during this time before failover may fail. If you're using private link to connect to your Key Vault, it may take up to 20 minutes for the connection to be re-established in the event of a failover. During failover, you won't be able to make changes to Key Vault properties. You won't be able to change access policy or firewall configurations and settings. After a failover is failed back, all request types including read and write requests are available. Setting 2. Getting started with Azure Key Vault. Up an Azure subscription. Create an Azure account. If you don't already have one, go to the Azure website and sign up for an Azure account. You'll need to provide payment information, but Azure offers a free trial with a credit of $200 to get started. Access the Azure portal. After creating your account, log into the Azure portal, https://portal.azure.com, using your Azure credentials. Subscription selection. If you have multiple subscriptions, make sure to select the subscription under which you want to create the Azure Key Vault. Click on your account name in the upper right corner and choose your desired subscription. Creating a new Azure Key Vault resource. Search for Key Vault. In the Azure portal, use the search bar at the top to find Key Vault. Select Key Vault from the search results. Create a Key Vault. To create a new Key Vault, click the +Add button. Key Vault configuration. In the Basics tab, provide a unique name for your Key Vault. Choose the Azure subscription you want to use. Select or create a new resource group, a logical container for Azure resources. Choose an Azure region for the Key Vault. Select one that is geographically close to your applications for better performance. Access policy configuration. In the Access Policies tab, configure the initial access policies. You can add specific users, service principals, or applications and grant them permissions, such as get, list, set, or delete for keys, secrets, and certificates. Advanced settings. Optional. You can configure advanced settings such as network and virtual network rules, but these are optional for basic setup. Review and create. Review your configuration, and if everything looks correct, click the Review + Create button. Create. After reviewing, click the Create button to start the provisioning process. It may take a few minutes for the Key Vault to be created. Configuring access policies. Access Policies tab. Once your Key Vault resource is created, go to the Access Policies tab in the Key Vault settings. Add new access policy. Click the +Add Access Policy button. Configure access permissions. Choose the principal, user, service, or application for which you want to configure access. Specify the operations, e.g., get, list, set, delete. They are allowed to perform on keys, secrets, and certificates. Save changes. After configuring the access policy, click Add to save it. Save access policies. Make sure to click the Save button at the top of the Access Policies tab to save all changes. 3. Key Vault Basics. Understanding keys, secrets, and certificates. Keys. Keys in Azure Key Vault are cryptographic key pairs used for encryption, decryption, and signing operations. They are crucial for data protection and securing communication. Azure Key Vault supports both software-protected keys and hardware-protected keys using hardware security modules, HSMs, for added security. Keys can be symmetric, single key for both encryption and decryption, or asymmetric, a pair of public and private keys. Secrets. Secrets are sensitive pieces of information such as passwords, API keys, and connection strings. They are often used for authentication and authorization purposes. Azure Key Vault allows you to securely store, manage, and retrieve secrets, reducing the risk of exposure due to insecure storage or hard-coded values in application code. Certificates. Certificates in Azure Key Vault are X.509 digital certificates that are used for secure communications, including SSL/TLS connections and code signing. They are typically used in web applications to secure data transmission. Key Vault simplifies the management of these certificates, including automated renewal. Creating and managing keys. Create a key. In Azure Key Vault, you can create a new key by specifying its name, type, RSA or ECC, key size, and other parameters. The key can be stored in a software-based or HSM-backed vault. Key rotation. It's a best practice to periodically rotate encryption keys for added security. Azure Key Vault makes key rotation straightforward, allowing you to generate new keys and update applications to use the new keys while still supporting decryption with the old ones during the transition. Versioning. Azure Key Vault supports versioning for keys. Each time you rotate a key or make significant changes, a new version is created, making it easier to manage and recover from mistakes. Storing and retrieving secrets. Store a secret. To store a secret, you provide a name and the secret's value. This value is encrypted and securely stored in Azure Key Vault. Secrets can be organized in logical containers within the vault for easier management. Retrieve a secret. To retrieve a secret, an application or user with the appropriate permissions sends a request to Azure Key Vault with the secret's name. Key Vault returns the decrypted value, allowing the application to use it. Access control. Access to secrets is controlled by policies and permissions. Only authorized users or applications can access stored secrets. Uploading and managing certificates. Upload a certificate. You can upload an X.509 digital certificate to Azure Key Vault. The certificate, along with its private key, is securely stored within the vault. Renew certificates. Azure Key Vault can automate certificate renewal, ensuring that your certificates remain valid. You can also manually renew certificates when necessary. Certificate usage. Certificates stored in Key Vault can be used for securing web applications, e.g., SSL/TLS certificates, code signing, and other scenarios that require secure communication and identity verification. Understanding these core concepts and their practical implementation in Azure Key Vault is essential for managing cryptographic assets securely and efficiently. Whether you're working with encryption keys, secrets, or certificates, Azure Key Vault simplifies the management of these critical security components in your applications and infrastructure. 4. Access control and permissions. Implementing Role-Based Access Control, RBC. Role-Based Access Control, RBC, is a critical feature in Azure that allows you to control access to Azure resources, including Azure Key Vault. RBC enables you to grant permissions to users, groups, and applications, defining their level of access and what they can do with Key Vault resources. Here's how to implement RBC for Azure Key Vault. Azure Portal Access. Sign into the Azure portal with the necessary permissions. Navigate to Key Vault. Locate and select your Azure Key Vault from the list of resources in the portal. Access Control IAM. In the Key Vault settings, go to the Access Control IAM section. Add role assignment. Click Add a role assignment to assign a role to a user, group, or application. Select role. Choose a role that defines the level of access, such as Key Vault Contributor, Key Vault Reader, or Key Vault Certificate Officer. Select user or application. Specify the user, group, or application to which you want to grant these permissions. You can search for them by name or email. Save role assignment. Click Save to apply the role assignment. Creating and managing access policies. Access policies are specific configurations within Azure Key Vault that define what actions a user or application can perform. Here's how you create and manage access policies. Azure Portal Access. Sign into the Azure portal and select your Key Vault. Access Policies. In the Key Vault settings, navigate to the Access Policies tab. Add Access Policy. Click Add New to create a new access policy. Configure permissions. Specify the permissions for keys, secrets, or certificates that the user or application should have, such as get, list, set, or delete. Select Principal. Choose the user or application to which you want to assign this access policy. Save policy. After configuring the access policy, click Add to save it. Defining permissions for users and applications. Permissions in Azure Key Vault can be fine-tuned to ensure the right level of access for users and applications. Here's how to define permissions. Access policies. Navigate to the Access Policies tab within the Key Vault settings. Create or edit access policies. You can create new access policies or edit existing ones to specify which operations, e.g., get, list, set, users or applications are allowed to perform. Principal selection. When creating or editing access policies, choose the specific user, group, or application that should have these permissions. Save changes. Be sure to save the changes you make to access policies. By using RBC and access policies, you can effectively manage and control who can perform actions on your Azure Key Vault resources, ensuring the security and integrity of your cryptographic assets. 5. Key rotation and versioning. Key rotation best practices. Key rotation is a crucial security practice that involves periodically replacing old cryptographic keys with new ones. This helps mitigate security risks and protect your data over time. Here are some key rotation best practices. Regular rotation. Establish a key rotation schedule based on industry best practices and compliance requirements. Typically, keys should be rotated every 90 to 180 days. Create new key versions. Instead of completely replacing a key, create a new key version. This allows applications to gradually transition to the new key while still supporting decryption with the old one during the transition. Automate rotation. Implement automation for key rotation whenever possible. Azure Key Vault provides automation options to generate new key versions and update applications with minimal manual intervention. Test the rotation process. Before implementing key rotation in a production environment, thoroughly test the rotation process to ensure it works seamlessly without disrupting applications. Monitoring and audit logging. Enable auditing and monitoring in Key Vault to track key rotation activities, providing visibility into who is performing the rotations and when they occur. Versioning and managing key versions. Key Vault allows you to create multiple versions of a key, which can be beneficial for various reasons, including historical data access. Storing previous key versions enables you to decrypt data that was encrypted with older key versions. Rollback capability. In the event of an issue with the new key version, you can quickly revert to a previous key version, maintaining service availability. To manage key versions in Azure Key Vault. Create new key versions. When you want to rotate a key, create a new key version rather than deleting the old key. This could be done through the Azure portal or programmatically using Azure SDKs or REST API. Version selection. When using a key, specify which key version to use if multiple versions are available. By default, the latest version is used. Key deletion. Older key versions can be safely deleted when they are no longer needed, following appropriate data retention policies. Using soft delete for key recovery. Azure Key Vault offers a feature called soft delete, which provides a safeguard against accidental key deletion. With soft delete enabled, deleted keys are retained for a specific period before they are permanently removed. This feature is helpful for key recovery and ensuring data integrity. Enable soft delete. Soft delete must be enabled at the vault level to use this feature. You can enable it during the creation of a new key vault or enable it for an existing one through the Azure portal or Azure PowerShell. Recovery period. Deleted keys are retained for a specified retention period, e.g., 7 to 90 days. During this time, they could be recovered if needed. Permanently delete keys. After the retention period, soft deleted keys are automatically and permanently purged from Key Vault. Using soft delete provides a safety net against unintentional data loss, ensuring that you can recover deleted keys and data during the defined retention period. These practices help you maintain the security and availability of cryptographic keys in Azure Key Vault while ensuring that you can adapt to changing security requirements and recover from potential issues. 6. Monitoring and logging. Enabling diagnostic logs. Diagnostic logs provide detailed information about the operations performed on Azure Key Vault, allowing you to monitor and troubleshoot issues. Here's how to enable diagnostic logs. Azure Portal access. Sign into the Azure portal. Select your Key Vault. Navigate to the specific Azure Key Vault that you want to configure diagnostic logs for. Monitoring section. In the Key Vault settings, locate the Monitoring section. Diagnostic settings. Click Diagnostic settings to configure the diagnostic logs. Add diagnostic setting. Click Add Diagnostic Setting to create a new diagnostic setting. Choose Logs. Select the specific diagnostic logs you want to enable, such as audit logs, access logs, or other relevant logs. Destination. Choose a destination for these logs, typically Azure Monitor, Log Analytics, or a storage account. Save settings. Complete the configuration and save the diagnostic settings. Once configured, Azure Key Vault will start sending diagnostic logs to the chosen destination, where you can analyze them for insights and monitoring. Monitoring Key Vault with Azure Monitor. Azure Monitor is a centralized monitoring solution that provides tools and insights for monitoring your Azure resources, including Key Vault. Here's how to use Azure Monitor for Key Vault. Azure Portal Access. Sign into the Azure Portal. Azure Monitor. In the Azure portal, search for Azure Monitor and select it. Insights and Metrics. In Azure Monitor, you can access insights, metrics, and logs related to your Azure Key Vault. Explore the Insights, Metrics, and Logs sections for data and monitoring options. Create monitoring solutions. Azure Monitor allows you to create custom monitoring solutions, dashboards, and alerts to track Key Vault performance and security events. Reviewing audit and access logs. Audit and access logs in Azure Key Vault provide records of activities related to key management, secrets, and certificate operations. Here's how to review these logs. Access the logs. To review audit and access logs, access the chosen destination where you configure diagnostic logs, e.g., Azure Monitor, Log Analytics, or a storage account. Log Analytics. If you use Azure Monitor with Log Analytics, you can run custom queries to analyze the data. Use the Custo query language, KQL, to create custom queries for specific insights. Storage account. If you chose to store logs in a storage account, you can access and review log data in storage containers or tables. Viewing events. Review the log data to gain insights into who accessed the Key Vault, what operations were performed, and when they occurred. You can filter and sort data to find specific events. Set up alerts. Consider setting up alerts based on specific events or patterns in the logs to receive notifications when certain activities or anomalies occur. Reviewing these logs allows you to monitor and ensure the security and compliance of your Azure Key Vault, helping you detect and respond to security incidents or issues proactively. 7. Azure Key Vault Integration. Integrating Key Vault with Azure Services. Azure Key Vault can be seamlessly integrated with various Azure services, improving the security of these services by centralizing and managing cryptographic assets. Here are some steps for integration with common Azure services like Azure Functions and Virtual Machines (VMs). Azure Functions. When developing Azure Functions, you can use Key Vault for storing sensitive information such as connection strings or API keys. Configure the Azure Functions application settings to retrieve these secrets securely from Key Vault. Use managed identities or service principals to grant your Azure Functions access to the Key Vault. Virtual Machines (VMs). You can securely store VM-related secrets in Azure Key Vault. VMs with managed identities can access Key Vault directly. Configure VM extensions or scripts to retrieve secrets from Key Vault during provisioning or runtime. Azure App Service. For web applications hosted on Azure App Service, integrate Key Vault for secure storage of application secrets. Configure the App Service's connection strings and settings to reference Key Vault secrets. Azure Kubernetes Service AKS. Secure containerized applications in AKS by connecting them to Azure Key Vault. AKS pods can use managed identities to authenticate and access Key Vault secrets securely. Using Key Vault with Azure DevOps. Azure DevOps is a powerful platform for managing the software development lifecycle. Here's how to use Azure Key Vault with Azure DevOps. Access control. Configure Azure Key Vault access policies to grant the necessary permissions to your Azure DevOps service connection. This allows Azure DevOps to read secrets from Key Vault. Service connections. In Azure DevOps, create a service connection for Azure Key Vault. This service connection stores the details needed to access the Key Vault, such as the Vault URL and the Azure AD service principal. Pipeline integration. Within your build and release pipelines, reference the Azure Key Vault service connection to retrieve secrets during deployment or CI/CD tasks. You can use the Azure Key Vault task in your pipelines to access secrets stored in Key Vault. Application-level integration with Key Vault. For application-level integration, follow these steps to securely access secrets and keys stored in Azure Key Vault. Authentication. Use either managed identities or service principals to authenticate your application with Azure Key Vault. Access policies. Define specific access policies within the Key Vault to grant your application the required permissions to read secrets, keys, or certificates. SDK or REST API. Utilize the Azure Key Vault SDK or REST API within your application to retrieve secrets, keys, or certificates securely. The SDK simplifies the integration process and provides built-in security features. Error handling. Implement proper error handling in your application to manage situations where Key Vault access fails or secrets are not available. Ensure that your application gracefully handles such scenarios. By integrating Azure Key Vault with your Azure Services, Azure DevOps pipelines, and your applications, you enhance the security of your data and simplify the management of sensitive information. This approach ensures that your secrets and keys are stored and accessed in a secure and compliant manner. 8. Best practices and security considerations. Key Vault security features. Azure Key Vault offers robust security features to protect your cryptographic keys, secrets, and certificates. Hardware Security Modules HSM's Azure Key Vault uses FIPS 140-2 Level 2 validated hardware security modules to protect cryptographic operations, making it highly secure. Access Control, Role-Based Access Control, RBC, and fine-grained access policies allow you to control who can access, manage, and configure Key Vault resources. Managed Identities. Azure Services and applications can use managed identities to authenticate and securely access Key Vault, reducing the need for credentials or keys. Secrets encryption. Secrets stored in Key Vault are encrypted at rest and in transit. Encryption keys are also managed securely by Key Vault. Auditing and monitoring. Key Vault provides detailed audit and access logs, helping you monitor who accesses your keys and when. You can integrate these logs with Azure Monitor for real-time insights. Soft Delete. Enabling Soft Delete ensures that deleted keys, secrets, and certificates are retained for a specified duration before permanent deletion, reducing the risk of data loss. Key Rotation. Key Vault supports key rotation, allowing you to periodically replace keys, enhancing security without disrupting your applications. Compliance and regulatory considerations. Azure Key Vault can assist in meeting various compliance and regulatory requirements. GDPR, General Data Protection Regulation. Key Vault helps protect sensitive data, making it easier to comply with GDPR by implementing strong security controls and encryption. HIPAA, Health Insurance Portability and Accountability Act for healthcare organizations. Key Vault can secure patient data and ensure compliance with HIPAA requirements. PCI DSS, Payment Card Industry Data Security Standard. By using Key Vault to protect encryption keys, you can meet the encryption and security requirements of PCI DSS for credit card transactions. SOC 2, Service Organization Control 2. Key Vault can help you establish the necessary controls for compliance with SOC 2, ensuring data security and privacy. FIPS, Federal Information Processing Standards. Key Vault's HSMs comply with FIPS 140-2, making it suitable for government and highly regulated environments. ISO 27001:2013. Azure Key Vault is ISO 27001 certified, demonstrating its commitment to information security management systems. Backup and disaster recovery strategies for Key Vault. To ensure the continuity of operations and data protection, consider these backup and disaster recovery strategies. Geo-replication. Enable geo-redundant storage for Key Vault, which replicates data to a secondary region. In the event of a regional outage, data remains available in the secondary region. Backup policies. Configure automated backups for your Key Vault resources. These backups can be restored in the event of data loss or accidental deletions. Soft Delete. Enable soft delete to retain deleted keys, secrets, and certificates for a specified period. This provides a safety net for accidental deletions. Disaster Recovery Plan. Develop and document a comprehensive disaster recovery plan that outlines the steps to restore Key Vault and access critical cryptographic assets in case of a catastrophic event. Regular testing. Periodically test your disaster recovery plan to ensure that it is effective in restoring access to your cryptographic assets and Key Vault resources. By utilizing Key Vault security features, complying with regulatory requirements, and implementing robust backup and disaster recovery strategies, you can safeguard your cryptographic assets and maintain business continuity even in challenging situations. 9. Use case scenarios. Use cases of Azure Key Vault. Azure Key Vault provides a secure and centralized solution for managing cryptographic keys, secrets, and certificates. Here are some common use case scenarios for Azure Key Vault. Secure application secrets. Store application-specific secrets, such as API keys, database connection strings, and passwords, securely in Key Vault. Applications can retrieve these secrets at runtime, reducing the risk of exposing sensitive information. Encryption key management. Use Azure Key Vault to manage encryption keys for data at rest and data in transit. This is crucial for securing confidential data in databases, storage accounts, and other Azure services. Code signing. Protect your code by signing it with the private key stored in Key Vault. This ensures the authenticity and integrity of your software, especially important for distributing software updates. Certificate management. Store and manage X.509 certificates in Key Vault for secure communications in your applications, including SSL/TLS certificates and client authentication certificates. Key rotation. Implement key rotation policies to periodically update encryption keys and certificates without disrupting applications. Key Vault makes it easier to manage this critical security practice. Securing virtual machines. Azure Virtual Machines can use Azure Key Vault to securely retrieve passwords and SSH keys, reducing the exposure of sensitive authentication credentials. Secure application deployment. When deploying applications to Azure, use Key Vault to store and manage environment-specific configuration settings securely. This ensures consistency and security across different deployment environments. DevOps integration. Integrate Key Vault into your CI/CD pipelines to store secrets and keys used in deployment scripts and automate the retrieval of these assets during deployment. Azure Functions and Logic Apps. Securely store connection strings and secrets required by Azure Functions and Logic Apps. This ensures that your serverless applications have access to sensitive information without exposing it in code or configurations. Secure service-to-service communication. Use Azure Key Vault to manage authentication tokens and secrets required for service-to-service communication, enhancing the security of microservices architectures. Compliance and auditing. Implement Key Vault to maintain compliance with data protection regulations and industry standards by securely managing cryptographic assets and maintaining detailed audit logs. Disaster recovery. Configure backup and recovery options in Key Vault to protect cryptographic assets against data loss and data encryption in databases. Use Key Vault keys for transparent data encryption in Azure SQL Database and other database services, enhancing data security at rest. Securely access Azure storage. Implement Azure Key Vault to manage storage account keys, ensuring secure access to Azure Blob Storage, Queue Storage, and Table Storage. These use cases demonstrate the versatility and importance of Azure Key Vault in securing your cloud applications and infrastructure. By using Key Vault, you can centralize and simplify the management of cryptographic assets while enhancing the overall security of your Azure-based solutions.
Please subscribe to my channel. Thank you.
Hey learners, don't just watch, hit that subscribe button, and let's dive into a sea of knowledge together.